Hi everyone. So in continuation with our lecture series on centroid, today we shall discuss a very important and interesting concept, that is centroid of a composite area. So here we are interested to find the location of centroid of a composite area. So let's understand first, what do we mean by a composite area? If we have x and y axis as a reference axis, friends, and the origin is O, so this is an area, we can say a larger area, which is a combination of small areas. Therefore this larger area is called as a composite area. The composite indicates the combination of small sections or small areas. In various engineering applications, we have to use many different types of areas or the sections of structure, and then we need to find out the centroid of the final section, that is the composite section. So here if you see, the final section or final area is a combination of various small individual areas, as you can see from the figure itself. Okay, now these areas, the smaller areas, will have their own centroids. You can see here, so this area has got its centroid here. Similarly, the second one is over here, third one is over here. So like that, there are n number of small areas, and therefore there are n number of centroids for these corresponding areas. So if I consider this particular smaller section, you can see here, so this smaller section or smaller area has got area A1, and its centroid will have x coordinate and y coordinate. So the centroid has x1 bar and y1 bar as their coordinate. Similarly, all the other areas, so if I say this one is area A2, this one is, let's say, area A3, this one is area A3, friends, A4, and so on. So I will say this one is AN, n number of areas we are having. So each areas will have their corresponding centroids. So now for the complete section, for complete area, there will be a location of centroid, that is called as the centroid of the composite section. So C basically indicates the centroid of the composite section. So C is basically the centroid of composite section or composite area, we can say. So here we are going to find out the x and y coordinate of the centroid of composite section. So the x coordinate is xc, friends, and y coordinate is yc. So let's see what is the procedure. So let's see how we can find out the coordinate of centroid for a composite area. So there is a simple mathematical outcome, friend. There is simple mathematical expression. Suppose I want to find the x coordinate of centroid, so that I am calling as xc, friends. So in this case, we take the moment of all areas, all individual areas, like x1 bar multiplied by a1. Then for second area, we will take moment, its moment of area, and that is x2 bar multiplied by a2. And for third one also we will take moment of area, friends, a3. Like that, for all individual areas, we are going to do the moment. For nth area, friends, we will have the moment like xn bar and an. So in the numerator, we got the moment of all area, and the denominator again we will be writing the areas together, all area, that is a1 plus a2. In denominator we are writing a1, a2, a3, sum of all individual areas, and then last one is an. So when you want to find the x coordinate of centroid, we take the moment of all individual areas with respect to y-axis, that is, the distance is going to be the x coordinate of that individual area. Okay, so this is how we find the x coordinate of centroid of composite section. Similarly, we can also find out the y coordinate of centroid of composite area, and here now we'll be taking moment of all individual areas with respect to x-axis. So that will be y1 bar times a1, y2 bar times a2, y3 bar times a3, and for all individual areas we'll be writing that is yn bar times an, and divided by the sum of individual areas in the denominator. In the denominator we'll have sum of all individual areas, that is a1 plus a2 plus a3, and so on. So this is how we can find out the x and y coordinate of centroid. So mathematically this can be expressed in the form of summation. So xc will be summation of x and a. So x is basically the distance from y-axis, and a stands for the area of individual sections. Okay, and in the denominator we have summation of all the areas. This is x bar we got, friends, and similarly we will be getting y bar. So this is x bar and this is y bar. So by following this simple procedure, you can find out the centroid of composite area. So now let's do one example to understand the concept of centroid of a composite area. So let's see, friends. So we are going to find the location of centroid of a given L section. So this L section is basically a composite section. Let me show you how it appears. So we have got a composite section, friends, which is also called as L section. So it has a vertical dimension which is 100 mm over here, and the horizontal dimension is 80 mm, and the thickness of this particular flange is 20 mm, and thickness of this web is 20 mm, right? So this is basically a good example of composite area. So whenever you want to find the centroid of any section, friends, we need to draw the reference axis. So reference axis is always drawn from the bottommost side to the leftmost side. Okay, so always the vertical axis must coincide with the leftmost side, and the horizontal axis must coincide with the bottommost side of the given section. That's how I'm drawing it. So you can see here the x-axis is coinciding with the bottommost side of the section, and the vertical axis is coinciding with the leftmost side of the section. So this is how we always draw the reference axis. Okay, so we have got x-axis and y-axis. So this point we call as centroid of composite section. So the point C is the centroid of the composite section, and it will have its y coordinate as yc and x coordinate as xc, and we need to find out the xc and yc by the procedure we have already discussed. In order to find the centroid of combined section, that is a combined composite section, consider this particular table. This table is very important. If you follow this particular table, you can easily find out centroid of any section. So if you see here, this table consists of section. So we are going to divide the entire composite section into individual sections. Okay, so how many individual sections we are going to get, that will be coming in the section part, and each section means each individual section or individual area will have its x coordinate and y coordinate of centroid. Okay, so we will see the centroid of individual area and we'll find out their corresponding x and y coordinate. Then we will take the area of individual section or individual areas, and then we'll find out the first moment, that is area times distance with respect to y-axis, means a into x we'll find out, and we also find out a into y. So these are basically multiplication of area with distance from y and x-axis respectively, and then we will find out the summation of a into x and summation of a into y and summation of area. So let's see how we can proceed with the help of this table. So first of all, I am going to divide the entire composite section into the individual sections or individual areas, small areas possible. Now if you see, so here we have got one rectangle. This rectangle is one individual area, and there is a bottom horizontal rectangle is another individual area. So I will name them. So this is the first area or first section we got, and the bottom one is the second area. So first of all, we will have to find out the separate sections which are forming the complete composite section. Okay, so this is first area I am calling, and this is the second area of section I am calling. So I'll name it in the section. So I have section 1 and I have section 2, friends. So there are two sections. If you look at here, the vertical rectangle is one section and the horizontal rectangle is another section. Now we will find out the centroid of each section. So centroid of section 1. So centroid of section 1, if you see here, this particular rectangle will have its centroid over here. So I can call this as centroid of section 1 for basic understanding. So it is going to have x and y coordinate, friends. So this is going to be x coordinate of centroid, that is x1 bar, and this is going to be the y coordinate of centroid of section 1, and you can call this as y1 bar. So we have got, for C1 we have got x1 bar and y1 bar. If you see the section 1 or area 1, it is a rectangle. So x will be half of its width. So its width is 20 mm. So x1 will be going to be 20 by 2, that is 10 mm, and y this much distance from here to x-axis, friends. Overall height is 100. So this height is going to be 80, friends. So this height is 80 mm. So this distance will be 40, and from here to here is 20. This is 20, friends. So I can say the y coordinate of C1 is going to be 40 plus 20, that is going to be 60. So I am going to get x as 20 by 2, that is 10 mm, and y as from here to here is 40 and plus 20, so 60 mm. Now if you see, we have to find for section 1 the area. Area is length times the height over here. So length is 20 and height is 80, so 20 into 80. So this part will be 20 into 80, friends. And the next one is A, that is area times x bar. So 20 into 80 into x bar is 10. So this is going to be 20 into 80 into 10. So if you see here, the area is 20 into 80 and x bar is 10. So 20 into 80 into 10 we got over here. Similarly, area times y bar. So area is again, friends, 20 into 80. And if you see here, y bar is 60. Now let's go for the section 2. So the bottommost rectangle is section 2 here. So its centroid, if I say, is going to lie at this particular point. So this is going to be, I can call this as C2, the centroid of second section, friends. So this is going to be the y2 bar from here to here, and this is going to be, friends, x2 bar, that is x coordinate of centroid. Okay, so if you look at carefully, the y2 is going to be half of its height. So its height is 20 mm. So half of 20 mm is going to be 10, friends. So I can say the y2 bar for second section, y2 bar is 20 by 2, that is 10, and the x2 bar will be 80 by 2, that is 40. So here you'll be getting x2 bar will be 40, friends, and y2 bar is going to be 20 by 2, that is 10. Now if you look at the area of the second section, it is, the length is 80 and height is 20, so 80 into 20 again. Now we want to find a into x bar. So 80 into 20 into x bar is 40. 80 into 20 into 40. 80 into 20 into 40. And similarly, I want to do a into y bar. So 80 into 20 is a, area of that, and y bar is 10. So 80 into 20 into 10, friends. Okay. So now we have got the data, whatever is required for us. So now let us calculate these things. So we required this thing, friends, here. So 20 into 80 is going to be 1600. So this is 1600. 80 into 20, this is also 1600, friends. So this value is basically 1600. I'm writing it in small way, and this value is also 1600, friends. Now 20 into 80, that is 1610. So it is going to be 16,000. 20 into 80 into 60. So if you multiply 20 into 80, that is going to be 1600 into 6. So 16 into 6 will be 96,000. If you calculate, you will get 96,000 here. This value is 96,000. Here 80 into 20 into 40, if you multiply, this value is going to be 64,000. And 80 into 20 into 10, if you multiply, this is going to be 16,000. So now what we have to do is, friends, we have to find the centroid. So for centroid, we need xc and yc, that is the coordinate of centroid, that is xc this one and yc this one. So we know that the xc is given by this particular expression. So what is xc, friends? Summation of area into x, so that is basically, it is a1, we can say x1 plus a2 x2 divided by a1 plus a2. So if I put the values, corresponding value, friends, so this is a1 x1 and this is a2 x2. So it is 16,000 plus 6,400, and that divided by, friends, a1 plus a2. So a1 is 1600 plus a2 is also 1600, you can see. So here if you see, friends, this is a1 1600, this is a2 1600. So a1 plus a2 is summation of a, basically. So if you add this, you will be getting 3200 here, and if you add summation of a into x, this and this value, you will be getting 80,000 here. And if you add a into y, these all values if you add, you will be getting 112,000 like this. Okay, so I've just made it for simplification. So if you look at here, this is a1 x1 plus a2 x2. It is nothing but a summation of a into x. So this is, we got 80,000. So if you add these two, you'll be getting 80,000, friends. So this is going to be 80,000, and denominator is, friends, 3,200. So if you solve this, the value of xc, that is x coordinate of centroid, will be coming as 25 mm. This is going to come as 25 mm, friends. And similarly, we'll go for y coordinate of centroid. So this is going to be a1 y1 plus a2 y2 divided by a1 plus a2. And if you put the corresponding values, so we have a1 y1, that is 96,000, and a2 y2 16,000. This is going to be 96,000 plus 16,000, and the divide by a1 plus a2 again 1600 plus 1600. So if you work out completely, this is going to be summation of A into I, we have already got 112,000, and divide by area, summation of area is 32,000. So if you solve this, friend, the value of YC, that is Y coordinate of centroid, will be coming as 35 mm. This value will be coming as 35 mm. So finally I can say that XC, that is centroid, is 25 mm, XC is 25 mm, that is X coordinate of centroid is 25 mm, and YC, that is Y coordinate of centroid, is 35 mm. So therefore, by following a simple procedure what we have explained here, you can easily find out the centroid of composite figure. We shall see some more examples similar to this to understand the concept of location of centroid of composite section. Okay, thank you very much.